So I got a few more things, and I got box number 1 done, box number 2 kind of prepped. And then, prototype. So this is setup piece. This is a revision of the setup piece. And then I'll tell you where I went wrong. So this dimension here, I gained 4 millimeters because each one of these bend radiuses, I didn't calculate them properly. So I did 179.4, and then I think, I'd have to do, it'd be this bend, my 261 minus 171, but minus 82. So 261 minus 82.26. That's, anyway. So I got the bends in, like everything turned in the way I wished. These little corners on my first one, I just cut it with shears. This one, I went 10 millimeters in on both sides. So it shows you just how much I lost in terms of material. So this 10 millimeter thing, so this is the width of the battery, right? So the battery and its pack, fit in this lip perfectly. And that's what I calculated to be 10 millimeters. So I was out by, this is about like 3 millimeters here, 4 millimeters here, 4 millimeters here. But then also my width is just a little big. So it's kind of like a origami, but it's like 3-dimensional, and then it shrinks. So what I need to do here is I need to do a bend radius here, bend allowance here and a bend allowance here. And then I need to recalculate this width here. So I have the battery box the way I need it to be. So how I got that wrong is, this end to end, that overhang should be more, it should be 15 millimeters. So I'm out by about 5 millimeters. The other thing I got in were these linear actuators, and I've not yet played with them inside here, but I've moved them. They're 12-volt aluminum, pretty heavy duty. And then with that, I got relays to control them. So they're pretty slow. So it's not like an H-drive, like a H-bridge circuit will be any beneficial. Like I don't need to speed them up or slow them down. At full power, they're slow. So this will be enable, forward, backwards. That's how I'm going to hook it up, I think. Enable, forward, backwards. Then I had these little things. So I used to build my own voltage regulators, but then Amazon had 10 of these for $20. And it is a LM2596 adjustable. So I gotta look it up, but I think it's like, I wanted 24 volts in, and it can go from 3 volts to I guess what your supply is, but they're super cheap. They're like $2 each. So I need a couple voltage, I need a couple supply rails. They're good for 3 amps, and look at how small they are, and they fit right in underneath there. So they have little bits of I can do plastic standoff or something. So look at that. So that's my 10 volt, or I'll be my 5 volt to supply for stuff. And then I'll need a second one to supply for the Achilles heel. I thought about putting this here because it ultimately gets cut with a shroud, or captured within a little shroud. I still might, maybe, we'll see. Okay, I need a comment on this. Do I put the Achilles heel on the back or on the front? So for me, the Achilles heel of this should pull back instead of pull down. So here it would be extended, and then to pull up, it goes this way. So here it's out, and here it there it's out, and then to extend and stand up, it has to pull in. So what I got was effectively the same thing as this, but it is a like a 2-inch stroke. This is an 8-inch for the foot retraction, as well as I figure another one, you know, there would be something like this inside that kind of matches the angle of this to rotate these. So on my list of things to do is figure out how to make it move with the Achilles heel. I don't know what to call the center foot. Well, it's just called center foot everywhere. And then, well, they call it 2, 3. So that would be wheel 3. 1, 2, 3. And then also the shoulder pivot. The battery boxes. There's a reference line. It tells me how high to put this. And in the process of doing this, mocking this up, I made these too big. So I also have this dimension to change. And why is that important? It's because when you go 2, 3, 2, the whole body swings and holds underneath. So much work to do.